click the red subscribe button right under the video and also the bell icon to get notification on any of our latest updates on videos.
Hello and welcome to another Smart Guides tutorial. My name is Fatima and we're going to do a bit about resolution of forces. So this is our question, and we're told that in the design of the robots here, to insert the small cylindrical part into a close-fitting circular hole, the robot arm must exert a 90 Newton force P, which is denoted as this, on the part parallel to the axis of the hole as shown. This is the axis of the hole. We're asked to determine the components of the force which the part exerts on the robot along this axis here. Now take note of this on here. What we're given in the question was the reverse of what was asked in the question. Now because of that, we are going to reverse the direction of our P. Instead of facing downwards, it will be facing upwards to give us the force which the part itself exerts on the robot, instead of what's the force that the robot exerts on the part. So we're asked to find the components of that force along axis which is parallel and perpendicular to the arm AB, that is this. So parallel to the arm AB will be in this direction, and perpendicular will be perpendicular to the arm, so we'll have something like this. And then parallel and perpendicular to the arm BC will give us an axis which looks like something like this and like this. So enough with imaginary drawings. Let's sketch this. So here we are. Our P was given as 90 newtons, right? So this is a sketch of what this question is asking us. So we can have an X and Y axis here where we can put in our given values. We're given a 15 degrees as the angle between the force P and the y-axis, that is the vertical axis. So we can put it here and we can just reverse the direction of the P. Then I started with the arm BC because it's kind of closer to the hole and it's kind of easier to start with. So I extended also the arm BC. Initially I could plot it here on this small axis here, and they gave us 45 degrees, which is this angle, and I projected it to give another 45 degrees here on this XY axis here. So this angle and this angle are corresponding, that's why they have the same magnitude. And I also transferred this force P to this axis here. They also correspond and they have the same magnitude, 15 degrees to the vertical. So as I mentioned earlier, we're asked to find the components of the force P on the axis which is parallel and perpendicular to BC. Now the axis parallel to BC is this one here. You can see it coincided with the direction of the arm BC in this direction, while the axis which is perpendicular to BC is at 90 degrees to the first axis here, which is TN. So our positive TT direction is in this side and our positive TN direction is on this side. So we can see that as we projected our force P here, it falls on the negative side of the TT axis but on the positive side of the TN axis. Now anyway, to calculate the P component on this axis, we need an angle which is either the angle between P and the TT axis or the angle between P and the TN axis. Now how about finding the angle between P and the TT axis? Now to do that, we know we already have 45 degrees here and a 15 degrees here. To find this angle alpha, we can subtract 45 degrees and 15 degrees from 90 degrees, which is a right angle on this axis here. So our alpha is going to be 90 minus 15 plus 45, which will obviously give us 90 minus 60, which is 30. To find our PTT, we simply say our minus to indicate that our force is on the left hand side, which is negative. then multiply by our P, which is 90 minus 90 cos our angle 30, and this will give us a negative 77.94 Newton. As for our PTN, it's on the positive side of the TN axis, so we simply multiply our 90 newtons and our sine 30. Now sine 30 is equal to 1 over 2, so 90 multiplied by 1 over 2 will give us 45 newtons, and that's that for our axis parallel and perpendicular to BC. Now let's revisit the question again. We're also asked to determine the components of the force which the part exerts on the axis along parallel and perpendicular to the arm AB, and that can be depicted by this. You can compare. So our arm AB is at 60 degrees to the horizontal, which I plotted here on this XY axis here. So I plotted this at this direction, and if this is point A and this is point B, the angle which is parallel to arm AB is going to be this line coinciding with AB. Then here is another axis which I drew to plot my 15 degrees, which is the given value of the angle between P and the vertical axis, that is 15 degrees here. So I then extended my given 60 degrees line here and plotted an angle perpendicular to it to give me my normal axis to the AB axis here. So I extended it to meet this axis around here. Now I also transferred my 15 degrees here to here. You can see they are corresponding angles, so they have the same magnitude. Now already we have 15 degrees here, 60 degrees here, while this is our axis of interest, this in orange. So to find our P component on the axis parallel and perpendicular to our arm AB, we need an angle which is either the angle that P makes with the TT axis or the angle that P makes with the TN axis. So you can decide to use the angle that P makes with the TT axis. Now to find that, we have to find this small angle here in between this 15 degrees angle and this 60 degrees angle. Now how do we find that? Already we know that this axis is 90 degrees, that is the XY axis is 90 degrees, and we were given 60 degrees as the angle that AB makes with the horizontal, which is this. So to get this angle, we can simply say this whole 90 degrees minus 60 degrees, which will give us 30 degrees, right? Then we add it to the 15 degrees here, because this is our axis of interest. Our angle lambda is the one that we're going to use, and it is composed of this 15 degrees and this space here. So this 90 minus 60 is representing this angle here, then plus 15, which is going to give us 15 plus 30, that is 45 degrees, right? So to find our PTT, we are going to simply say P cos 45 degrees, and to find our PTN, we're going to say P sine 45 degrees. Sorry, this is lambda. So yeah, we have P cos lambda and P sine lambda. To find our PTT, we multiply P, which is 90, cos our lambda, which is 45, and this gives us 63.6 newtons. Then our PTN is going to be the same as our PTT. 90 sine 45 is also going to give us 63.6 newtons. So now we have gotten the components of the first P that it makes with this axis, this axis, this axis, and this axis. So that's all for this question. Thanks for watching.